You walk up to your pond early in the morning and notice something strange. Your fish are gathered at the surface, rhythmically gasping for air. It is easy to assume they are just hungry and waiting for a morning feeding, but these fish aren't begging for food. They are physically struggling to breathe. Ignoring this behavior is essentially starting a countdown. If the water quality doesn't change, the entire population will likely collapse. Fish don't breathe air like we do. They rely on their gills to extract microscopic molecules of oxygen that have been dissolved directly into the water. When those dissolved oxygen levels drop, fish instinctively swim to the very top layer of the pond. Because this water is in direct contact with the atmosphere, it often holds the highest concentration of oxygen left in the pond. We can visualize this ecosystem as a balance between supply and demand. Supply comes from the atmosphere and plants, while demand is created by the fish and the bacteria living alongside them. This relationship is the oxygen equation. Keeping the fish alive requires managing the variables that keep these two sides in equilibrium. Several factors can cause the demand side to spike. The most common is overstocking, which forces too many fish to compete for the same limited pool of oxygen. Then there is overfeeding. When you provide more pellets than the fish can eat, in a few minutes the leftovers sink to the bottom and begin to rot. As feed rots, massive bacteria colonies multiply, stripping the water of the oxygen molecules fish need. The same happens after an algae bloom. Dead algae sinks, increasing the bacterial workload and driving oxygen even lower. Any excess organic material added to the water drives up the biological oxygen demand and tips the scale towards suffocation. While demand is rising, the supply side shrinks. This usually happens during the peak of summer. Warmer water is physically unable to hold as much dissolved oxygen as cold water. As the pond temperature rises, your available supply of oxygen molecules literally escapes into the air. During the day, living plants and algae help replenish this supply by producing oxygen through photosynthesis. But at night, photosynthesis stops. Those same plants switch from producing oxygen to consuming it, competing with the fish for the remaining supply. This drain continues throughout the night, meaning oxygen levels reach their lowest point in the hours just before sunrise. When a hot night combines with rotting organic matter, the oxygen supply can crash entirely before dawn, triggering the gasping symptom in your fish. If you see fish gasping at the surface, you must intervene immediately by forcing atmospheric oxygen into the water. This is best achieved with mechanical aeration, like paddle wheels, air pumps, or fountains that keep the water churning. Agitating the surface breaks the water's tension, which physically allows oxygen from the air to dissolve into the pond. In an emergency without specialized gear, even running a standard water pump or manually splashing the water can create enough movement to buy your fish time. Aeration is the most direct way to bypass a natural supply crash and inject life-saving oxygen back into the system. While aeration solves the immediate crisis, long-term health depends on keeping the demand side of the equation low. This requires a disciplined feeding schedule. Only provide what the fish can consume in a few minutes to ensure you aren't unintentionally feeding the bacteria at the bottom. You must also maintain appropriate stocking levels and regularly remove the organic waste and dead algae that accumulate on the pond floor. Every fish in the pond is physically dependent on the concentration of dissolved oxygen in the water. If that concentration drops, their metabolic processes simply stop. Subscribe for more science-backed aquaculture tips. In the next video, we'll explore another common pond challenge and the steps you can take to solve it.